past several lessons, you have been multiplying polynomials. In other words, you have multiplied two factors to create a polynomial. In today's lesson, we're going to reverse the process. We are going to start with a polynomial, which is the product of two factors, and we are going to determine the factors. The process is called factoring polynomials. In order to factor polynomials, you must be very good at multiplying polynomials and adding, subtracting, and dividing polynomials. Like many of the things that we have discussed, factoring is really based on the distributive property. For real numbers a, b, and c, a times b plus c is ab plus ac. Now to factor, we're going to reverse the process. So we're going to say ab plus ac is equal to a times the quantity b plus c. So notice we just used the symmetric property of equality to reverse the process. So we're going from the product to the factors. Let's look at an example. Let's factor 2x plus 4y. Now just on first glance, you cannot see that we have anything in common. A 2 and an x and a 4 and a y. But what I can do, I can break 4 down into 2 times 2 to get 2x plus 2 times 2y. In other words, I factored 4y into 2 times 2y. Now notice that both of them have the common factor of 2. Just like up here, both of these had the common factor of a. So I can take the 2 outside the parentheses by the distributive property. Now I'm left with x plus the 2y inside the parentheses. Now I'm going to give you a rule for factoring polynomials by removing the greatest common factor. This is a starred rule, so therefore you need to memorize it. You also need to place it on your study sheet. To factor a polynomial by removing the greatest common factor, which from now on I will abbreviate as GCF, first of all, you identify the greatest common factor. And the greatest common factor will be the first factor of the answer. To identify the greatest common factor, you need to first of all look for the largest integer which will divide all numerical coefficients. You want to find the largest integer which will divide all numerical coefficients. Second, you want to find variables common to all terms. You're looking for variables common to all terms, and you want to take the variable raised to the smallest exponent. So the second part of your common factor will be the variables common to all terms raised to the smallest exponent on the variable. Now once you identify the greatest common factor, then you need to divide the polynomial by the greatest common factor to get the second factor. So you divide the polynomial by the greatest common factor to get the second factor. Let's look at an example. Let's factor 8x squared y plus 16x cubed z. For the first factor, we want to, I'm going to put one here, we want to get the greatest common factor. We want to get the GCF. The first step in getting the greatest common factor is to find the largest number that would divide all of the numerical coefficients. The numerical coefficients are 8 and 16. So we want the largest factor that would divide both 8 and 16. Well, that is 8. Next, we want the variables in common. Both of them have an x, and that's the only variable they have in common. Now, I want x raised to the smallest of the exponents. Exponent 2, exponent 3, so I'll take exponent 2. the greatest common factor is 8x squared. 8x squared is the largest factor that would divide both of these. 8 is the largest number that will go into both 8 and 16. X squared is the largest power that will go into both x squared and x cubed. Since 16x cubed z does not have a y, and 8x squared y does not have a z, they do not have common factors of y or z. So the only common factor is 8x squared. So 8x squared is going to be the first factor. Now what we want to do is to get the second factor. To get the second factor, I take the 8x squared y plus 16x cubed z, and I divide by the common factor, which is 8x squared. Well, to divide, I would have 8x squared y divided by 8x squared plus the 16x cubed z divided by the 8x squared. Doing the division, 8 goes into 8 1. X squared divided by x squared would be x to the 0, because I keep the base, subtract the exponents. Y plus 2 x to the first z. Or I can write this as y plus 2xz. So that's my second factor. So I have my first factor, I have my second factor. Now I need to write the answer. The answer is going to be the first factor, 8x squared, times the second factor, y plus 2xz. And circle your answer so that I'll know that you think it is the answer. 8x squared times y plus 2xz.